Hi guys, welcome to my talk ES7, the evolution of JavaScript. First I'll talk a little bit about myself. I'm Netflix's cross-team technical lead. I work across all the various UIs. I'm the architect of Netflix's UI data platform, and most importantly for this presentation, I'm on the TC39, which is the JavaScript Standards Committee. Now, ES6, the forthcoming version of JavaScript, will be standardized in June 2015. So you'd be forgiven for asking the question, isn't it a little too early to talk about ES7? Well, as a matter of fact, the answer is no. In fact, you might be surprised to learn that features are actually rolling in to browsers right now from ES7. So I think the important thing for most JavaScript developers out there to understand is that ES7 is not going to be like ES6. ES6 was a major release that came a long time after ES5, whereas going forward, the committee is moving more towards like a train model, like we use for software, where every year we're going to be releasing rapidly, and those features that just aren't ready won't make it into that release. So ES7 is going to come not too long after ES6. So with ES7, what we're doing is we're really building on top of ES6. And this co-evolution, this co-design of ES7 and 6 means that we can really start to think forward and sort of intelligently plan what's going to go in ES6 and how they're going to play together. And that's a lot of what I'm going to be talking today in my presentation, about how ES7 features build on top of ES6 to solve the types of problems that web developers are facing. So the first feature I'm going to talk to you guys about is arrow functions. And this is one of my favorite features from ES6 because it really allows you to write functions in a much more terse way. Now, most people are familiar with how you write a function in ES5. Now, starting in ES6, you'll be able to get rid of a lot of this boilerplate and actually shrink this down to a simple arrow. So I'm going to be using this particular usage of the arrow function throughout the slides going forward. Now, I know there's a lot of folks out there who use an MVC framework. Now, today I want to focus on one particular part of the MVC triangle, and that's the model and view. Now, a lot of people out there use frameworks like Ember or Backbone, and all of these different frameworks have different approaches to doing model-view synchronization. And none of them is sort of really one out. They all have their, their benefits and drawbacks. Now, Ember, for example, forces you to go through special setters and then does dirty checking. Angular waits until after every event and then diffs the model from what it was before, and Backbone.js sort of leaves it open and you can sort of figure it out yourself. Now, all of these approaches, as I mentioned, have positives and negatives. So the question is, why can't JavaScript support change notification natively? I mean, if all these frameworks are doing this, why can't we help out and basically improve the performance of this approach and come up with one approach that works for everyone? Well, that's the first JavaScript 7 feature I'm going to talk to you guys about, which is Object.observe. Now, I think a few folks out there have heard of Object.observe. It's probably the most popular, it's probably the most discussed, the most publicly discussed feature of JavaScript 7 up to this point. Now, let's take a look at how Object.observe works. Let's say I want to observe a person object, for example. So as you can see in this slide, I'm going to create a changes handler. Notice that arrow means function. And I'm going to hook it up to the person using this Object.observe method.
Now what's going to happen if I register a changes handler, there as you can see below with Object.observe, is I'm going to get a little batch of changes explaining what happened. So in this case, if it's an array, there's just one item in there, and it tells me that I updated a property, and it tells me which property I updated. It also helpfully gives me the old value. The next thing I can do is I can, let's say for example, add a new property. Let's say Dana starts working at the Tommy's Box Star. Well, we get a new notification that tells us a new property was created and the name of that new property. Now, let's say it's pretty unlikely this person's going to change their name, so I'm actually going to use object-defined property to set it to be writable false. You can't change it anymore. Now, I'm actually even going to get a notification that, you know what, this property was reconfigured. It's not going to be changed. So finally, I can decide, well, I don't want to work at Tommy's Box Store. It doesn't sound like a very fun place to work anyways. And I get a notification that a property's been deleted. Now, these 4 simple notifications allow us to do our model and view synchronization. Now, most developers aren't going to use Object.observe directly. Probably one of the frameworks that you're using will take advantage of it. But it's interesting to know how we manage to do these updates efficiently, because if we're not careful, and some of you may have run into this problem, if you do object view synchronization, model view synchronization, and you're not careful, you can end up with some really poor performance characteristics. So how do we avoid that? Well, first of all, before we move on, if you observe something, you got to be able to unobserve it, right? So we have observe and unobserve. Now, some of you English majors back there in the back may be thinking to yourself, well, unobserve is not a word, right? Well, Irregardless, we're going to use it because English doesn't make sense, and that's what we're going to do. So let's explain. Now, what we do is we batch up these changes in Object.observe to make sure that we don't, like every time you change a property, we don't go and change the view. But if you were to do this yourself today in ES5, I mean, sure, you could make some setters, and every time a setter was made, you could schedule some change, like asynchronously to update, and then collect up all the changes and do it yourself. But if you weren't careful, you might end up with this problem. So here's the event loop queue, and let's say in your event handler, you decide to make a change to our person friend. Now, that's going to generate this observe notification. But if you post that onto the end, say maybe with a set timeout, onto the end of the queue, what's going to happen is maybe the next task is a browser render, and it's going to happen before we can even respond to that Object.observe notification and update the view. And so you'll end up with the dreaded notification storm. Yes. So how do you avoid the notification storm? Well, we're going to use a new feature introduced in JavaScript 6. We're going to take advantage of something called microtasks. Who in this room started microtasks? Far fewer people. Well, microtasks is actually a very important feature, but it's not a public API that you can use. Right now, it's actually built into JavaScript. And it's actually a very important release, JavaScript 6, because JavaScript's doing something it never did before. It's actually taking some control of the event loop away from the browser. Now, in the old world, the browser, we just let the browser handle the event loop. The JavaScript engine would just wait for the browser to call in, and then you'd post something back, and the browser would entirely control the event loop. In JavaScript 6, we're doing something subtly different. We're sort of taking more control. We're asserting more control over the event loop so that we can do something very interesting called a microtask. Now, as I said, this microtask, what it does is it actually allows me to post a task to be done, but instead of posting at the end of the event queue, well, I can actually make it happen as soon as the current task stack bottoms out to 0. So let's take a look at what that looks like. Well, so same thing as before. We have tasks on the event loop. Our event handler fires. We change some properties on the person, and we generate a handler. But this time, we use the microtask scheduler. Object.observe uses the microtask scheduler to schedule it. So let's see what happens. It actually just jumps to the bottom, and as soon as the stack bottoms out, we run the microtask. That means it happens before the browser render. And that is how Object.observe efficiently allows you to propagate changes throughout your system before the browser renders. Now, microtasks were actually introduced for promises. Promises are a new feature being introduced in ES6. I'm sure there's a lot of people in the room who've heard of promises. Quite a few. How many are using them today? A lot. Again, this is why we're interested in them on the committee. And so you might be using a promise library today, but you'll find in JavaScript 6 we've actually introduced the promise type so that everybody can sort of take advantage of this common interface. And I'll talk about promises a little bit later. But one of the penalties of using promises today, depending on how you're doing them, is that promises also always fire your handler asynchronously. But let's say sometimes, as we know, once a promise is resolved, it's actually got your data sitting right there waiting for it. So if you then that promise, well, we don't want to have to post it to the end of the event loop to give it to you, so we use a microtask. So that's why microtasks were added to JavaScript 6, and now as you can see, we're taking advantage of them to build new features in JavaScript 7. You're going to see that trend continue. So you can try Object.observe today. All you have to do is enable experimental JavaScript in Chrome. The folks at Google have been working really hard in pioneering this feature, and they're using it in their framework called Polymer, which is a really interesting framework that you can play with. Object.observe also has interactions with web components, which is an interesting proposal in the HTML space, and it may be how JavaScript and the DOM can talk, just talk to each other more effectively. So Object.observe, now in order to responsibly talk about JavaScript 7 at this early stage, what we need to be able to do is talk about the maturity stages. Now, Object.observe is a draft. Now, this is one of the reasons why it's so important to emphasize that the actual spec date of JavaScript 6 or JavaScript 7 doesn't matter very much, because what we're doing is we're applying this notion of feature maturity stages to each individual feature. Now, if an individual feature maturity stage tells you as the developer whether you can comfortably use it or not, we might say, you know what, some parts of the spec are really, really polished, we feel confident about them and you can start using them, and some parts of the spec, they're very, very early and you probably shouldn't try using them yet. So right, as you can see, Object.observe is still in the draft stage, and we're probably going to be iterating it, moving on it, iterating it for a while. And there may be some decisions and changes made, so to some degree, use at your own risk. But we still want to encourage your use, because the draft stage really means the committee expects the feature to be developed and included in the standard. We'll talk a little bit more about the other feature maturity stages as we move through. So one question that I think is on a lot of people's minds, and I alluded to earlier, is how JavaScript 7 can make asynchronous programming easier. So I think it's fair to say asynchronous pain is a pain point for most JavaScript developers out there. JavaScript is a single-threaded language, after all. And so we constantly have to deal with asynchronous sources of information. And trying to piece them together with callbacks and sometimes even promises can be challenging. And there are some problems promises don't even solve. So let's talk about those. Well, here's a great example of some synchronous programming that's just real easy, right? We love it when programming is this easy. It's synchronous. I call this function. I call that function. I return the result. It's great. But what happens if I try in the old world in ES5 without the help of any kind of promise library? What happens if I try and make this algorithm async? Well, I find myself in the pyramid of doom. What does the pyramid of doom look like? Well, those who are node programmers have probably seen this before. Now, by the way, I'll liberally be using JavaScript 6 syntax here in my presentation. So is everybody familiar with the arrow key, fat arrow there? Hands up quickly if somebody's familiar with how it works. OK, about half and half. So the great news is that the arrow function, as you can see up there, arrow is shorthand for function. So when I'm passing that arrow, where I've got an error and a symbol, I'm actually passing a function, a callback, with an error and symbol. And this is something that we've introduced in JavaScript 6. As you can see, it's going to make your code a lot shorter when you're dealing with passing functions around. And very importantly, it's also going to make my slides a lot shorter, so I can fit a lot of code on slides. So quick show of hands. Who understands? Who feels like they kind of get that? It's just a shorthand for a function? Great. OK, so I'm going to be using fat arrows everywhere. So take a look at that. But we can see one of the problems with the pyramid of doom is that when we're doing synchronous programming, we have try-catch to help us, right? When there's errors that occur in a synchronous program, we can catch it up here, we can catch it down there, we can catch it anywhere, because we rely on JavaScript to propagate up errors for us and unwind the stack. But when we go to asynchronous programming, we have no such luxury. So we, as the developer, have to sort of worry about forwarding on errors. Now, I know there's a lot of people in the room who know about promises, and so you might be thinking, well, I've got a great answer to that, and in fact, we do. So notice the error handling code we've had to add there makes our code a lot bigger. Promises are a feature that are being introduced in ES6. Now, as I could see, a lot of you guys are out there using promise libraries, and the reason we introduced promises into JavaScript 6 is because the DOM wanted to start using them for a variety of reasons. And so the web is really moving towards promises as a standard and something you can use going forward. So how do promises work? Well, they're really pretty simple. You call the .then function, and you pass in a success handler or an error handler. And so there's really two ways a promise can go. First is it can give you data. Next is it can give you an error. So now let's see how we can take our synchronous algorithm and we can write it asynchronously using promises. Now that's clearly a lot better. Now we don't have to worry about forwarding on errors, because the way promises work is that whenever an error occurs, they forward it up until the first error handler is passed to then, and then you can catch that error there. So in this case, we're just going to return this promise, and whoever happens to call getStockPrice can add an error handler when they call then, in the event that an error happens. And they probably should, because stuff goes wrong when you make network queries. But as good as that is, I think we can still do better. Now, as you can see, the structure of the async code is still very different than the structure of the sync code. And we still kind of have that pyramid structure going on a little bit there with the thens. We don't have the error handling, but we still have that pyramid structure. And developers were not used to seeing that pyramid when we're doing sequential operations. And so it can be a bit confusing. So the committee is asking ourselves, can we do even better to make asynchronous programming and synchronous programming look the same? What's frustrating is that sometimes as developers, we know that when we write a synchronous program and an asynchronous program that's equivalent, we want to be able to write them the same way and have them look the same way. So how can we do better? Well, we can actually do a good deal better just in JavaScript 6. I'm not even talking about JavaScript 7 right now. If we understand, basically something that happened 20 years ago. Now, 20 years ago, who has this book? Who's seen this book? Very influential book, released 20 years ago by the Gang of Four. It's four folks who worked to look at the industry and looked at all the patterns people were using, and they tried to codify those patterns so that we couldn't keep doing things differently even though they were functionally the same thing. Now the Gang of Four built this big list of patterns, design patterns, that they took to look at the industry and they codified. And this, by the way, is almost 20 years ago today. I think it was just like a couple of weeks ago. Now, I want you to take a look at these patterns, but today we're only really going to be focusing on 2 of them. Now this diagram shows how they thought different patterns were related to each other. But today I want you to just take a look at these 2 patterns, iterator and observer. We're going to be talking a lot about the iterator and observer pattern because they're the key to how we can really start to write asynchronous code in a much more elegant way than we have before in the web community. So one thing they did is, well, sorry, just to rewind a little, one thing they did is you notice there that the Gang of Four didn't think the iterator pattern and observer pattern were related. There's no line that goes between these 2 patterns. And that was a mistake, and we'll talk a little bit about that 20-year-old mistake and how it impacts the way you write asynchronous code today later on. So I suggest that the iterator pattern and the observer pattern are related, and I'm going to talk about that in a second. So first of all, who knows about iterators? Who feels like they're comfortable with talking about iterators? Well, we're only probably seeing about 1/3 of the room because iterators are a very new concept in JavaScript, but they're very, very common that you find in other programming frameworks. The way an iterator works is simple. You have a producer and you have a consumer. And the way the iterator pattern is basically a way for a producer to give a consumer data 1 item at a time. Now in the iterator pattern, the producer pulls data out of the consumer. The consumer is basically in control. It says, give me the next value, give me the next value. So why would I use the iterator pattern? What's great about it? Well, I'll show you guys a little bit later, but it's nicer sometimes than returning an array because what it does is it means you can return values progressively. Instead of doing a bunch of work and creating a big collection and then handing it off to the consumer and the producer can kind of have an ongoing conversation where the producer or the consumer says, give me the next value, and then you just compute the next value. So let's see how that works. So we have our consumer and producer. Now the consumer, first it requests an iterator from the producer. It says, hey, give me an iterator. And we see the iterator comes out. Now the consumer says, you know what, give me the next value. So we see it's calling next. And what happens is the producer produces the next value, sends it to the consumer. That process repeats. You can keep getting values and cranking them out until finally we ask for the next value and the producer says, you know what, I'm done. I got nothing more for you. So that's relatively straightforward. And in fact, all ECMAScript 6, all JavaScript 6 collections are iterable. So all of the new collections, we have maps and we have sets and we have arrays. All of that stuff is iterable. And that means that you can pull data out of these collections in exactly the same way, no matter what it is. So let's take a look at how that actually works. So first, you request an iterator. This could be a map, it could be a set, it could be an array. Once you've got it, you call next. And you get out this little pair. I want you to take a look at this little pair. It's a pair that has the value, and it also has a little Boolean telling you whether or not you're done. Now we can keep doing it again because we're not done. Next value. Finally, we call next and we find out we're done. And so we know that we can't ask for any more values. So this really simple pattern, this by itself might not seem that impressive, but I can show you how it's going to allow us to do really impressive things coming up. So iterators are very cool because they can do things you can't do with arrays, like create infinite collections. Collections that just go on and on and on forever. Now, why would such a thing be useful? Why would I want to create an infinite collection? Well, there are actually interesting uses for infinite collections. And in fact, you use them all the time. And I'm going to come back to that later. You may not be aware of it. But here's how you can use this special new syntax introduced in JavaScript 6 to be able to create an infinite collection and be able to just express it this way. So what's going on here? Who's familiar with the yield keyword? Who's heard of the yield keyword before? So a few people. So it's not probably obvious to everybody what's going on in this piece of code. So let's demystify yield. Let's figure out what's actually going on. Well, I want you to rewind. Before we take a look at that, I want you to rewind and think to yourself, what if you had to write the iterator function over an array? How would you do it? Such that every time I called next, I pulled out the next value of the array. Well, you'd have to build some sort of state machine, right? This iterator object has to kind of remember where it was last time, and then the next time somebody calls next, it gives you the next value. So what yield does is it builds the state machine for you. This is perhaps the most powerful compiler transformation that JavaScript can do today. You write your code and it looks one way, and we translate it into something that looks completely different. So as you can see, first of all, we take this code and we nest it inside of an iterator. We return this little object that's got a next method that you keep calling to get values out. Then what we do is JavaScript figures out every possible state your function could be in, and then it builds this state machine for you. Is that cool or what? It actually figures out what's going on. And so now, last we can see every single time we return a value, it turns those yields into this little return value, and it attaches that little property telling you whether you're done or not. Trust me, this is going to come back to asynchronous programming. So now, the great news is, just as we support creating iterables in JavaScript 6, we also support consuming them. In fact, every single iterable in JavaScript 6 allows you to just consume it the exact same way, which is using this new for of loop. Now, be careful. Take a look at that. That's not for in. That's for of. Well, we probably would have liked to use for in, but for in was taken, as most of you know now, for doing reflection in JavaScript. So we use this for of. So whenever you see for of from now on, that's our way of, under the hood, doing the exact same thing that you saw in that earlier code, requesting the iterator, calling next, calling next, calling next, and then doing something with the value. So this is just syntactic sugar for this example right here. Make sense? Everybody understand the for of loop? So that's what's coming in JavaScript 6. Again, we haven't even started to talk about JavaScript 7 yet. So I told you earlier I was going to talk about two patterns, the iterator and the observer pattern. Now, let's focus on the observer pattern for a second. Most of us know the observer pattern in JavaScript as pub/sub. We are all used to using the observer pattern. In fact, we use it all the time. DOM events. Right? As soon as I move my mouse and subscribe to this event, I'm going to get an event stream. Now, this is data that's being pushed at the consumer. Now, the iterator and the observer pattern really have a lot in common if you think about it. Pulling values out of an array and being pushed values from an event is not that different. In fact, both the iterator and the observer pattern are both about a producer sending a consumer one item at a time. The gang of four who wrote the design patterns, they missed this. They didn't see this correspondence. And as a result, today on the web, programming against push streams of data and pull streams of data looks very, very different. But it doesn't have to be that way. So let's take a look at yet another example of a totally different API for getting a push stream of data. Well, set interval, console log, right? Again, it's basically the same thing. It's a producer pushing data at us, but totally different API. Go figure. So the web has tons of these APIs, all different sort of flavors of APIs, DOM events, WebSockets, server-sent events, node streams, service workers, jQuery events. XML HTTP request has a progressive mode where it can pass you data as the HTTP 1.1 as packets arrive. That's got its own API. Set interval, yet another push API. Why do we have all these different interfaces for pushing data from producer to the consumer? Well, it all goes back to that little mistake made in the design patterns all those years ago, where they didn't realize that these two patterns were basically about the same thing. And so today we have this proliferation. And why that's a problem is that while everybody knows how to do iterators, iterators are common in most platforms. JavaScript, Java, .NET, all of them have iterators, C++. You see the same pattern again and again. The same way of pulling data out of a producer, but you see total variation in ways that we push data from a producer to a consumer. And that makes it hard to add language support for this pattern. So what if we could fix it? Well, the important insight here is that iteration and observation are symmetrical. This is something we really just figured out 5, 6 years ago, and it's based on the work of people like Brian Beckman and Eric Meyer, and it's recent enough, and it's had enough time to just state and be proven out in a variety of frameworks, that it's something that JavaScript might be able to benefit from, and might be one of the first languages to be able to benefit from. Imagine if you could for loop over an array the same way you could for loop over an event. And we'll talk about that in a second. So again, the web platform has no standard observer interface. But in JavaScript 6, we've added a new API. We've added a new interface, excuse me, the observer interface. And we've made sure that it's symmetrical with the iterator interface. Because one of the problems with the gang of four, one of the mistakes they made with the observer interface is with the iterator, they defined 3 things you could do. You could get data, the producer could tell you there was no more data, and whenever you requested data, Well, it could throw, and so you could get an error. So the producer could tell the consumer, data, I'm done, or error. But when they wrote the Gang of Four, when the Gang of Four wrote the observer pattern, all they did was just give the way for a producer to send a consumer data. They didn't bother to add a way for the producer to say to the consumer, you know what, it's done. Or a way for the producer to say to the consumer, there was an error. And that doesn't make any sense, because these patterns are basically about the same thing. And that's why we see totally different ways for sending errors between WebSockets or XML HTTP requests. But if we standardize on them with this new interface, we can add really powerful language support to JavaScript to be able to manipulate events and write async code in almost exactly the same way that we write sync code. So enough talking. Let's take a look at how the iterator pattern can be replaced with the observer pattern. What's the difference? Well, the observer pattern, we saw in the previous example that the iterator pattern, the consumer requests an iterator from the producer. Well, here with the observer pattern, the consumer hands an observer to the producer. It's the same thing, but flipped. The producer hands an observer. The consumer hands an observer to the producer. Now, this observer, all the producer does is it generates items, and then it calls next on the observer. Notice that the 42 is in the argument position. We're sending. This is just like invoking a callback. This is like what you do when you subscribe to the mouse move event. You hand the mouse move event your callback using add-event-listener, and then it pushes it, it calls it. It kind of, in a way, iterates you. And that's what's going on here. It's calling next, and it sends 42 to the consumer, and then it just generates another value, sends 39 to the consumer. Notice the consumer has no control. It's the producer that decides when information is sent. The producer is pushing information at the consumer. And that's what's different about the observer and consumer and the observer and iterator pattern. Notice now the observer has this new return method, which allows the producer to say to the consumer, you know what, I'm done, no more data, just like the iterator. Now that we've made these two patterns symmetrical, let's see what we can do. But before, let's take a look at let's take a look at this type that's introduced in JavaScript 6 called a generator. A generator, who's heard of generators, by the way? Quite a few people. Who feels like they understand them? Yeah, less hands. Generators are easily the most complicated and misunderstood and difficult to explain feature in JavaScript 6. And if you come away from nothing from this talk, I want you to understand how generators work, because they're the key to some of the most powerful things that you can do in JavaScript today. So how do we create a generator? Well, we take the iterator pattern and the observer pattern, and we squeeze them together into one type. So let's see what this looks like. A generator is an iterator. You can pull values out using that first API. I can pull a value out from the producer. The producer can throw an error when I try and call next, and then I have to catch it. So the producer can send me an error when I pull the value out. And finally, the producer can tell me this, remember that done property that we got before? If the producer sends me back that little pair and the done is true, that's the way of the producer telling me that, you know what, there's no more data. So those three semantics. Now the generator is also an observer. In addition to being a data source, which is an iterator, it's a data sink. It's something that can absorb information. And so you can receive data from a generator. You can receive an error by calling throw, and you can receive a return value. So iteration and observation by themselves only allow data to flow one way. Right? Either you're pushing data one way from a producer to a consumer, or the consumer is pulling data one way from the producer. But generators allow feedback. Generators are kind of like a way for two functions to have a long-running conversation. So check that out. So you can pull a value out and then push a value back in. And that's actually the basic mechanism that's going to allow asynchronous programming to get a heck of a lot easier in JavaScript 7. And even in JavaScript 6. So let's take a look. So today, we see that this is the way we write the synchronous and asynchronous functions. And they're still, they're pretty good, but they still look very different. Well, what if we could write it like this instead? That looks a lot better, doesn't it? It looks actually a heck of a lot cleaner and clearer and pretty much the same as the synchronous code. So what have we actually built here? Well, we saw how yield works earlier. What we built is an iterator of promises. This function, getStockPrice, Now all we need now is a consumer for somebody to ask for an iterator and pull the first value out, which is going to be a promise. Then what they're going to do is fulfill that promise and send the value back in. Let's take a look at how this works. So all we need is somebody to drive this now. So you can see here, yield. Yield isn't a statement like return. It looks like a return, but it's not. It's actually an expression. And I'm going to show you how that works in just a second. So also an expression. So you can get a value out of yield. How does that work? Well, here's how iteration plus feedback works. Same thing as before. We call our function getStockPrice, and we get out an iterator. Now we ask for the next value from that iterator, and now we stop at that yield point over there. That yield point returns a promise, the promise that we get from getStockSymbol. Now the consumer takes that promise, and there's an agreement between the consumer and the producer. You know what? The producer says, you know what? If I give you a promise, fulfill that promise before you ask for the next one. And so the consumer fulfills the promise, gets out the result, and then the next time it calls next, it sends the value back in. Next actually accepts values in at the same time as it returns values out. And so we're sending in this value, and now we can see why yield is an expression. It just gets replaced with the value that we send back in. Does everybody see how iteration plus feedback works? Let's see how, and then we just pick up right where we left off. We move on to the next, we call the next function, we create another promise, we send it to the consumer, consumer fulfills it, sends the value back in, we move to the last statement, return, and the value comes out along with the message that it's done. That's how iteration with feedback works, and by using this pattern, we can write code that's async that looks almost identical to sync. So here's how the process works in code. Let's take a quick look at it. So I've written this special async function. This async function is the consumer, and our getStockPrice function is the producer. So we're going to first write this function on result, which we're just going to keep passing to the promises, thenning to the promises we get back from the producer. So I call this function, we jump up here, I ask for the first result from getStockPrice. We get out a promise. Then I call then on that promise and recursively pass in the same function. So whenever this promise fulfills, it's actually going to call on result, and we're going to pick up right where we left off at the top. We're going to move down here, and now notice the result of the promise is Johnson & Johnson. It's the JNJ. We pass that into next, and we pick up there in the top function, and now all of a sudden the yield expression has been replaced with the answer, JNJ. We yield the price promise, we pass then to it, we recursively go up, and now we get the result as 420.25. Call next, send it back in, get the price, and jump down to the bottom, because now we don't have a promise anymore. That's the way the consumer works. It just keeps asking for values, and if they're promises, it fulfills them, sends the value back in, and asks for the next one. And then at the very end, when there's not a promise anymore, it just returns it. And what does async return? A promise. So let's see how the whole thing works together. At the very end, we get 420.25. Using Task.js, which is a framework that you can go out on the internet and grab today, and JavaScript 6, you can actually write code like this today. If you're using the advanced JavaScript features, or you're using what's called a transpiler, which is software that you can use out there to compile JavaScript 6 into JavaScript 5, and I'll be talking about that a little bit later. So that's how we can now write asynchronous functions that look exactly the same as equivalent synchronous functions, or almost exactly the same. I'll just let that slide sink in. Well, so that, by the way, that's the consumer and that's the producer, right? So we're clear on that. One consumer function, one producer function. Now, that's JavaScript 6. That's something you can actually do today, either by turning on advanced features in your browser or going and getting what's called a transpiler. But in JavaScript 7, we're going to make this even easier. Why all this ceremony about having to create this spawn function when you can just make all of that go away and add async await? Introducing the async await keyword. Now you know exactly how async await works. It's not exactly true, but you can basically think of it as sugar for this pattern of iteration with feedback. So writing, in the next version of JavaScript, writing synchronous code and asynchronous code can look pretty much exactly the same if the functions are equivalent. So that's great if you happen to be writing a bunch of sequential operations, right? So async functions are also in the draft stage. Now, the draft stage, as I mentioned earlier, the committee expects the feature to be developed. It will make its way into JavaScript in all likelihood, right? And so you can start playing with this today as well. You can actually go and get Regenerator, which is something Facebook has written. Regenerator is a really powerful transpiler that can take your JavaScript 6 code and compile it directly into JavaScript 5 code. And it's even got a branch with async await on it. So you can even go straight from the async await that you saw earlier to your code today and start playing around with this feature. Now, async functions are going to be easy in JavaScript 7. But a lot of the people in this room, since we're at HTML5DevConf, are web developers, right? And we don't just deal with promises. We deal with another async event, or async source, which is events. We're always working with events. Mouse moves, right? WebSockets, streams of values. Is it possible that we can work with in-memory collections and events in the same way? Well, first of all, I'm going to call your attention to this table. Now, with the introduction of function star, we have a synchronous function that can return multiple values. And of course, a function just returns a single value synchronously. But now with the introduction of asynchronous functions that returns a promise, now there's a question. There's an empty part of this table. What is an asynchronous function star? Well, so if an asynchronous function star returns a promise and a function star returns an iterator, what would this return? Ask yourself. Anybody have an idea? Observable. Somebody said observable. Yeah. Pardon? A generator. Generator. Good question. Anybody else? Event, a stream? Stream, like a node stream, for example? All reasonable answers to this question, right? I will tell you what my particular opinion is. So if a function star differs from a function because it returns multiple values, an async function differs from a function because it pushes its value instead of pull it out. I submit that an async function star pushes multiple values. What pattern does that? The observable. The observable pattern that I showed you earlier. That's the pattern that pushes multiple values. It's basically the equivalent, the synchronous, the symmetrical equivalent of an iterator. So let's take a look at what that looks like. This is the observable that we talked about earlier. So if an async function star, what would this do if we yield 1, 2, 3 with this async modifier in front of the function star? Well, I am introducing this, I'd like to see this interface introduced called the observable. And the way it works is an iterable, like the array and set and map in JavaScript 6, allows you to request an iterator on this, what's actually a generator. The observable accepts from the consumer, accepts a generator. So we've just swapped the arguments and the return type. So how does async yield work? Well, this is an oversimplification because it's a little bit big to fit on a PowerPoint slide, but you get the basic idea. First of all, you notice we're using microtasks here. Now, if you give an observable, your observer, you might not want it to fire immediately. Just like promises, we want it to fire asynchronously. And so we're using this hypothetical API, which right now is private and internal, called setMicrotask, to make sure that this doesn't happen synchronously immediately. But notice, we call next, now when we yield, we're pushing values into the observer. So it's the same thing, but in reverse. So the observer pattern, here's how you might consume data from an observable. Pass in the observer side of the generator. So we pass in the next method, the throw method, and the return method. So we've got all the same three semantics as when we have with an iterator. We can get a value pushed at us, we can get an error pushed at us, and we can be told, you know what, no more data. Like that. So just like the iterator pattern where you request the iterator and you keep calling next, that's a little cumbersome. So why not add some sugar to make it easier? Well, we can do a little bit better by adding a for each method, just like what's found on array. If you call for each on an observable, what you get out is a promise that completes when the for each is done. Because unlike on an array where for each is going to complete synchronously, for each on an observable will complete asynchronously. And so it returns a promise. And then we can then that promise and catch any error or final value that's returned. Now notice there, the next method actually doesn't get anything out. When you for of over an iterator, you don't actually get the return value. And so to be equivalent on the other side, you don't actually get the return value, the value that comes along with that last done and value when you're working with the observer as well. But we can probably do even better than this. If we can create a for of for iterators, why can't we create a for on for observables? For on allows us to treat, for the first time, event streams exactly the same way as pull streams, as iterators. Now that we know that they're equivalent and symmetrical, why would JavaScript as a language treat them any differently? Why not provide the same language support for both? So what happens when I run this particular piece of code? Well, it's an async function, so we know it's going to return a promise. And when that promise completes, we know that the async function is completed. Now, you can only use for on inside of an async function, because you can't really use it outside because it's asynchronous. So let's see what happens. Now, I can take any of the push data sources out there on the web, WebSockets, XML HTTP requests, set interval, and I can turn them into observables, and then I can for on them. So here I'm going to create a WebSocket, and it's just going to track all the signups coming in from Netflix, all the people who have just signed up, and then I'm going to for on them, and I'm just going to write them. Now, I notice I've run that function in line, which means it's created a promise, which means it's going to start running immediately. Does that make sense? Who finds this a little confusing? Who's still trying to wrap their head around it? Right, still a few hands. It's absolutely difficult to think about event streams the same way that we thought about pull streams, because we have 20 years of thinking about them differently. But there really isn't any fundamental difference. Anything you can do to an observable, you can do to an iterable. And that means we can provide the same language support for both. So I agree, it's a little bit mind-bending, but over time, you'll start to realize that they're actually equivalent. So we can take any of those push APIs out there, convert them to observable, and use the same types of operations, language support, that you saw earlier on them. So here's event composition with an observable. What if I want to create a mouse drag stream? Now, with languages like, frameworks, like underscore, lots of the times underscore and other libraries come along and they introduce new methods for combining things like iterators or arrays together. Now, you could see the same thing happening for observables. And in fact, libraries already exist to combine observable-like types, and you can start using those today. But basically, this would be the type of code that you could write to build a drag and drop. Now, notice this take until method. Now, as soon as you can have an observable that can say, I'm done, you can combine it with another observable and basically start listening to one observable stream until another observable stream fires, and then make the whole observable stream say, I'm done. So what are we doing? Well, we're for looping over all of the mouse downs. And then within that, we're for looping over all of the mouse moves. But we want that to stop. We want that observable to stop the next time the mouse up fires. And then we just yield the mouse move. And this whole function creates a stream of mouse drags for a given DOM element. Imagine doing an autocomplete box this way. What is an autocomplete box? Well, we listen for keystrokes, and then we go and get a request from the server. But one of the problems with the autocomplete box is that, let's say I type A, and then I make a request to the server. And I type B, and then I make another request to the server for AB. Is there any guarantee that my request for the server from A is going to come back before my request for AB? No, we deal with race conditions all the time when we're working with async programming. With the operator take until, what I can do is I can say, you know what? For every key, loop through this get search result set. It might be a WebSocket of the various search results, but then as soon as another key is pressed, I can stop listening to those old search results and just start getting the new search results. So I can for loop over events. There's really no difference. We can think about them in precisely the same way. So you can actually try this today without the benefit of the syntax by downloading one of these two libraries. Who's heard of Bacon.js or RX? So quite a few people. So you already know that this type of event composition is possible. And I highly encourage you guys to go download and try out these frameworks. Netflix actually uses RX, and we do this type of event composition all the time. So I'm running out of time here, but I do want to talk about asynchronous I/O. Because it's really easy to take event streams and combine them together, as I just showed you before. But asynchronous I/O is something that a lot of JavaScript developers, particularly Node developers, worry about, because it's pretty hard. Right? It's kind of double-sided async. You can write some data, but then you have to wait until you've finished writing asynchronously before you can read the next piece of data. Well, you can actually use, so let's kind of think about it for a second. Iteration with feedback, the example we showed before, is where a consumer pulls out a promise, realizes that promise before pulling out the next value. Well, we can use observation with feedback to do the same thing to solve asynchronous I/O and make it look exactly like synchronous I/O. So here's an example of synchronous I/O. Let's say I want to use the synchronous I/O in Node. Almost nobody uses synchronous I/O in Node. It's generally a bad idea. But this is how I would write sync I/O. Here's a getStocks function. It's pulling stocks out of a file. And here's a writeStocks function, which is absorbing those stocks and writing them out to another stream after it first gets the stock price. That's really easy. That's pretty straightforward using the new for-of loop if you want to be able to iterate over those stock prices as they come out of a file. Imagine if you could deal with async I/O by writing this. All we've done is we've made the async function, both async functions. So we call await on reader.readline, because reader.readline now returns a promise. When that promise is realized, we get the string. And then we yield it to the consumer. In this case, since it's an async function, we're pushing it at writeStockInfos. Now, writeStockInfos is going to first go and grab the stock price for that particular name, and it's going to pause. It's going to grab the price, and then what's it going to do? It's going to turn around and write to the output stream, which also is going to return a promise. And that promise, the promise that comes back from writing to the output stream, actually gets replaced with yield JSON parse line up at the top there. And so we await, the producer awaits that promise that's come out of the stream before sending more information. So I know it can be a bit difficult to understand this by looking at code, so let's visualize it. We have a producer. Same thing as before. The consumer gives an observer to the producer. Now, we read some data out of a file. We push it to the consumer. Now, the consumer tries to write it out to a stream, but that stream's async. And so what comes back? A promise. Now, what the consumer does, is pass that promise right back into the producer. And there's an agreement. The producer is not going to push another value, not read another value off the stream until that promise is fulfilled. And then it reads another value off the stream, sends it in. We try and write that out. We get back a promise. It gets sent back. Producer fulfills that. And then no more data. Iterator and iterator and observer can be combined together to allow us to write async code in a phenomenally similar way to sync code. So here's what async I/O could look like in JavaScript 7. Now, this proposal is what we call a straw man. I'm going to skip through this because I'm running out of time. But it's important to understand that this proposal is by no means as mature as Object.observe or as async function. We're still really piecing out how this is going to work, and we're looking for feedback from the community. This is what's called at the straw man phase of the maturity proposals. And so that means we're allowing for feedback. And so there's a couple of other ES7 proposals. I'm running out of time, so I can't talk about them very much, but they're much more simple. Those are by far the most complex proposals right now being proposed for JavaScript 7. In JavaScript 6, you can sort of unroll an array in the middle of another array by going ... In JavaScript 7, we're proposing you could do the same thing with another object. You could unroll an object right inside of another object. That just means looping over it, copying the properties from one object to another. And we're also hopefully adding array.prototype.contains for those of you who are tired of typing index of not equal to -1. Nice. So resources, how can you get involved? If you're interested in the development of JavaScript 7, and I assure you JavaScript 7 isn't as far away as you think it is, you can get involved by either joining the ES Discuss mailing list, or visiting esdiscuss.org to take a look at the previous, the history of the mailing list. You can also check out Regenerator, which is this really cool piece of software that allows you to do almost everything except for the async function star stuff that I showed you today Just take it, compile it against code, and it'll turn it into JavaScript 5 code you can run today and try it out. And Task.js, which will allow you to sort of plug the iterator and promises together to write async code pretty much the same way as you write sync code. Any questions? In the last minute or so we have? Maybe some blown minds? OK, thank you very much, everybody.